Bismillahirrahmanirrahim. When one door of happiness closes, another opens, but often we look so long at the closed door that we do not see the one which has opened for us. Today, topic of my presentation is counting rules of probability distribution, binomial distribution. Learning outlines are fundamental counting rule, permutation rule, combination rule, probability distribution, binomial distribution. Learning outcomes. At the end of presentation, participants will be able to describe counting rules of probability and binomial distribution and their application. Counting rules. To determine the number of all possible outcomes for a sequence of events, following through rules can be used. The fundamental counting rule, permutation rule, and combination rule. The fundamental rule. Fundamental counting rule is used to find the total number of outcomes in a sequence of events. In a sequence of n events in which the first one has k1 possibilities and the second event has k2 and the third has k3 and so on, the total number of possibilities of the sequence will be this: k dot k1 dot k2 dot k3 dot, and this dot represents to multiply. Now coming to examples, a coin is tossed and a die is rolled. Find the number of outcomes for the sequence of events. So solution is, since the coin can land either heads up or tails up, and since the die can land any one of the six numbers showing face up, there are two events. So this 2 and we will multiply because there are 6 outcomes. So multiplying these together we get 12 possibilities. And this is a tree diagram that is shown for the sequence of events. These 2 events for the coins and these 6 events for the die. Okay, now it's coming to second example. A paint manufacturer wishes to manufacture several different paints. The categories include color: red, blue, white, black, green, brown, yellow, type, latex, oil, texture, flat, semi-gloss, high gloss, use, outdoor, indoor. How many different kinds of paint can be made if a person can select one color, one type, one texture, and one use? A person can choose one color and one type and one texture and one use. Since there are 7 color choices, 2 type choices, 3 texture choices, and 2 use choices, the total number of possible different paints is that we have 7 colors, 2 types, 3 textures, and we have 2 uses. So multiplying these together, like 7 2s are 14 and 14 3s, and then so on. So we get the number 84. So we have 84 possibilities. Factorial notation. These rules use factorial notation. The factorial notation uses the exclamation point. Like 5 exclamatory mark, it means that we will break it up to 1. 9 exclamatory mark means 9, 8, 7, 6, 5, 4, 3, 2, 1. To use the formulas in the permutation and combination rules, as we are going to use it ahead, a special definition of 0 exclamatory mark is needed, which means 0. Now, permutation rule. This rule is used to find the number of ways that R objects can be selected from N objects. The arrangement of N objects in a specific order using R objects at a time is called a permutation of N objects taking R objects at a time. It is written is N capital P small r, and the formula is this: N exclamatory mark over 9 minus R. This notation is used for permutations. Okay, in this we have to remember that order is very important. We have to arrange the objects in a specific order, then we will apply this formula. Suppose a business owner has a choice of 5 locations in which to establish her business. She decides to rank each location according to certain criteria such as price of the store and parking facilities. How many different ways can she rank the 5 locations? Now, 5 exclamatory mark means there are 5 locations, so we will split it like 5, 4, 3, 2, 1, and this dot means to multiply, and multiplying these values we get 120. So the 120 are different possible rankings. The reason is that she has 5 choices for the first location, 4 choices for the second location, and 3 choices for the third one, etc. So applying the permutation rule, 5 locations were taken and then arranged in order like this. So 5 exclamatory mark over 5 minus 5 because we have same number of n and r. So 0 exclamatory mark means 1, and these multiplying these values together we get 120. Okay, now suppose the business owner in previous example, as we discussed earlier, wishes to rank only the top three of the 5 locations. So now we will have R3 and n will remains constant, that is 5. So how many different ways can she rank them? Solution is 3 locations were selected from 5 locations. So n is equals to 5 and r is equals to 3. Hence the same formula, and 5 4 3 2 1 over 2 1, because subtracting 3 from 5 we got 2, so 2 splitting 2 into 2 1, then we will cut these same values up and down and we will get this 5 4s are 20 and 23s are 60. Now coming to combination rule. A selection of distant objects without regard to order is called combination. This is very important, that without regard to order. Combination rule is used to find the number of ways that R objects can be selected from N objects. Combination are used when the order or arrangement is not important as in selecting process. So the number of combinations of R objects selected from N objects is denoted by small nc and this small r, and is given by the formula. The difference between the permutation and combination rule is the difference in order. But in permutation rule, we arrange the objects in order, specific order. In this we did not. And this in combination rule, this r is also used. That is n exclamatory mark over n minus r exclamatory mark and then r exclamatory mark. Now coming to examples, how many combinations of 4 objects are there? Taken 2 at a time. So applying that previous formula as we discussed just now, that is 4 exclamatory mark because we have 4 total objects, then 4 minus 2 because in this case we have R2. So applying this, we cancel the same values up and down and we get 2.3, that is 2 3 the 6. A bicycle shop owner has 12 mountain bicycles in the showroom. The owner wishes to select 5 of them to display at a bicycle show. How many different ways can a group of 5 can be selected? Again, total 12 mountain bicycles we have, and out of them 5 are selected to display at a show. So that is R, we have 5 and N is 12. So subtracting 12 minus 5 we get 7 and then 5, and we split this value of 5, that is 5 4 3 2 1. We subtract it up and down and we get the multiplying these values we get 792. Now summary of counting rules, which we discussed just now, that is fundamental counting rule, permutation rule and combination rule. In fundamental counting rule, the number of ways a sequence of n events can occur. If the first event can occur in K1, the second event can occur in K2, and this is the formula for fundamental rule. This dot represents to multiply. Permutation rule, the number of permutation of n objects taking r objects at a time, that is order is important. And here you can see the difference between the formula. Combination rule is the number of combinations of R objects taken from n objects, and order is not important. So this is the main differences between these three. Okay, now coming to the second topic, probability distribution. It is a listing of the probabilities of all the possible outcomes that would occur if the experiment was done. It can be described as diagram like probability tree, table, mathematical formula. Now probability distribution is further divided into two groups: discrete probability distribution and continuous probability distribution. Discrete probability distribution is further divided into binomial distribution and Poisson distribution, and continuous probability distribution is further explained as normal distribution. As we have discussed this normal distribution, Poisson distribution in our previous lectures, today we will discuss binomial distribution in detail. First, we will see what is discrete distribution and continuous distribution. In discrete distribution, random variable can take only limited number of values. So, and what is random variable? A random variable is a quantity that can take any one of a set of mutually exclusive values with a given probability. So we can derive probabilities according to every possible value of the random variable. For example, number of heads in two tosses. Now, continuous distribution, random variable can take any value. We can derive the probability of the random variable x taking values in certain ranges because there are infinitely many values of x. For example, height of students in the class. Binomial distribution. The word binomial literally means two numbers. A binomial distribution for a random variable x, known as binomial variate, is one in which there are only two possible outcomes, success and failure, for a finite number of trials. However, we define success and failure, the two events must be mutually exclusive and complementary. That is, they cannot occur at the same time. And the sum that it is called mutually expressive, and complementary means that the sum of the probabilities is 100%. Now this is the formula where p bracket capital X is equals to x. Capital X means random variable and small x means number of successes, and this is the combination of x successes from n trials, as we know how to calculate, we just discussed. And p is small p, x means probability of success dot 1 minus p. Here we can also use q, and this is probability of failure, that is calculated by 1 minus p, and this small x means number of failures, where pq should be greater than 1. P plus q is equals to 1 because probability cannot be more than 1. X is a discrete random variable which may take on only countable number of distinct values such as 1, 2, 3, 4. Now, assumptions for binomial distribution. For each trial, there are only two possible outcomes on each trial, S success and F failure. The number of trials, that is N, is finite. For each trial, the two outcomes are mutually exclusive. P capital S is equals to P is constant, and PF, that is failure, probability of failure, Q is 1 minus P. The trials are independent. The outcome of a trial is not affected by the outcome of any other trial. The probability of success, small p, is constant from trial to trial. Now, parameters of binomial distribution. The two parameters that describe binomial distribution are small n, the number of individuals in the sample or repetitions of a trial, and the second parameter is small p, that is the true probability of success for each individual or in each trial. Mean of binomial distribution is NP, that is small n and small p. Variance is NPQ or NP bracket 1 minus p. As we have discussed, the Q is failure, and P is probability of success, and N is mean. Now, coming to skewed distribution, we can see the effect of changing probability on a binomial distribution when we have small sample size, that is 15, and if probability is less than 0.5, then the binomial distribution graph is skewed to the right, and if probability is greater than 0.5, then it is skewed to the left. Now, coming to examples of binomial distribution, a die is tossed 3 times. What is the probability of no 5s turning up, 1 5 turning up, and 3 5s turning up? Now, this is a binomial distribution because there are only two possible outcomes. We get a 5 or we don't. So, n is equals to 3 for each part. Let x, because coins were tossed for 3 times, so n is equals to 3, and capital S is number of 5s appearing, and we have 3 cases that no 5 is appearing, that is success rate is 0, 1 5 is appearing, that is success is 1, and 3 5s are appearing, means x is equals to 3. So applying that formula, we get this value 0.57 in case we don't have 5s up. In case we have 1 5 up, we get this probability 0.3, and in case we have 3 5 ups, we get the probability this 4.6 raised to power minus 3. Examples two. Example number two. Hospital records show that of patients suffering from a certain disease, 75% die of it. What is the probability that of 6 randomly selected patients, 4 will recover? This is a binomial distribution because there are only two outcomes. The patient dies or does not. Let capital X is number who recover, where n is equals to 6 and x is equals to 4. Let p is equals to, that is success means that they are alive, 0.25, and failure is that they die, and we get it by 1 minus 0.25, that is 0.75. So applying these values, this is the combination of success, as we know how is calculated through combination rule, and then applying this formula we get the value 0.03. Now, general applications. Binomial distribution occurs whenever there is a success and fail. The outcome may be trial or had success or and failure, wrong and right. Some general examples are: a fair coin is tossed 5 times, probability of obtaining the head. A baseball player comes to bat 4 times in a game, the chance of strikeout for this player is 30%. Applications in real life. If a new drug is introduced to cure a disease, then it either cures the disease or does not. If a person purchases a lottery ticket, then he is either going to win it or not. The number of successful sale calls, the number of defective products in a production run, the experience of a house agent indicated that he can provide suitable accommodation for 75% clients. If 6 clients approach to him, then what is the probability of 4 clients? So in such cases, we apply binomial distribution. Now coming to MCQs. A story has 6 TV graphic magazines and 8 news time magazines on the counter. If 2 customers purchased a magazine, find the probability that one of each magazine was purchased. Options are 6 by 91, 8 over 91, 48 over 91, 2 over 91. So any guesses? Okay, the right option is C, and this is how, because here we have 6 TV graphic magazines and 8 newstime magazines, and if two, because two customers, if 2 customers purchased a magazine, then the probability will be, that is, we will calculate 6 8s are 48 like this, and the 91 we will calculate through combination rule. Now, MCQ number 2. There are 8 married couples in a tennis club. If 1 man and 1 woman are selected at random to play in the summer tournament, find the probability that they are married to each other. The correct options are, possible options are 1 by 8, 1 by 4, 1 by 2, or 1 by 64. Okay, the right
1 by
option.
64.
Yes.
Dr. Meha, you have to wait for the answer, please.
Okay, ma'am. So right option is D, that is 1 by 64. This is how we calculate it. Since there are 8 ways to select the man and 8 ways to select the woman, there are 8.8, that is 8 multiplied by 8, or 64 ways to select 1 man and 1 woman. Since there are 8 married couples, the solution is 8 by 64, or we can say 1 by 8. Now MCQ number 3. There are 4 blood types, A, B, and O. Blood can also be RH and RH positive and RH negative. Finally, a blood donor can be classified as either male or female. How many different ways can a donor have his or her blood? Any guesses?
16.
Okay, let's see. Your answer was right. This is how, because we have 4 blood types, and the RH possibilities we have 2 out of 2, and the gender were 2. So multiplying these possibilities, like 4 into 2 and then into 2, we will get 16. This is the total number of possibilities. Now the digits 0, 1, 2, 3, and 4 are to be used in a 4-digit ID card. How many different cards are possible if repetitions are permitted? 5, 25, 225, or 625? Any guess? Okay. Now let's see what will be the right answer. Since there are 4 spaces to fill and 5 choices for each space, so multiplying these like 5.5.5.5, that is 5 into 5, then into 5, that is 5 raised to power 4, we will get the value 625. Now, in the old days, there was a probability of 0.8 of success in any attempt to make a telephone call. This often depended on the importance of the person making call or the operator's curiosity. Calculate the probability of having 7 successes in 10 attempts. Any guess?
Dr. Khansa, would you please like to answer this question? All the correct answers today are given by Dr. Mehreen. I'm so proud of her. I want Dr. Khansa, Dr. Amber, you are also senior PGRs. You should give the answers. Okay, Dr. Khansa, do you have any guess about this answer? Dr. Amber, would you please? Okay.
Okay. Let's see what will be the right option. Actually, probability of success, as we have seen in our example, is P is equals to 0.8. So Q will be 0.2 and capital X is success in getting through. So probability of 7 successes in 10 attempts is, we will apply that the same formula of binomial distribution and we will get the number 0.2. This is C7. We will apply this here's a combination rule, and here 7 is the success rate and 10 minus 7 will the failure rate. So calculating these values, you will get 0.2. MCQ number 6, find the number of ways in which 3 components can be selected from a batch of 20 different components. 1140, 840, 1040 and 900. Again, this is a calculation question. The right answer will be A. This is how we calculate it, by applying combination rule. That is, we have total 20 combinations and we have to select 3 out of them. That is, N is 20 and R is 3. So applying these values and calculating, we will get 1140. Now, MCQ number 7. 60% of people who purchase sports cars are men. If 10 sports car owners are randomly selected, find the probability of success and probability of failure. This is very easy question. Any guess about the answer? Yes. Right answer will be A, because 0 points, as 60% of